Alright, hello. Thought I wanted to continue with the monadic parser and fix a couple of issues that we had. So we're currently implementing this parser for any type of language or whatever. And right now we've made this little what you can say, toy program language, basically, that it's basically just evaluating these statements one after the other and getting a result. So basically very simple. And last time we ran into an issue with expressions. So where is it? Yeah, basically an expression is any of these things. So we have like an add expression and so on. Now the problem here though is that this add expression is in itself, the first thing that it evaluates is an expression, which probably is wrong. Yeah, so this is the problem here, like, because you should be able to get an expression here, but the problem is we are now in an infinite loop because the expression could be an add expression, so we're evaluating that. Okay, it's an expression, so the first thing needs to be an expression. Okay, so we go back to expression, we check add expression. Okay, we go back to add expression, the first thing is an expression, and so on. So we're basically just looping infinitely here. So I'm thinking one possible fix would be to make a separate thing here that would be, just check if it's an identifier or a number. Like, we would just want one thing and not a binary expression like this. So I've never done this before, but I think I'm gonna try and read up a little bit on this later. But I'm just gonna do this as a temporary solution probably. So let's just have a singular expression, which just means, I don't know, that we have just one thing and not like a binary operation or anything like that. So we have an identifier or number literal. So we'll just have this. And so now the first one is now a singular expression, but the second one could be another add operation, because you could have like that. So that makes it so that you can have a string of adds. So basically like this, it will support this here. All right, so let's actually try this over here. Okay. Now, where are we? Here. Okay, so, but these could also be an expression. So let's we could actually, let's divide this up into like multi-expression or what, something, I don't know really what to call this. And then singular expression, and then this is just either a multi or a singular. Okay. Then now we need to fix these two to be expressions instead. So this one is string to identifier, so we should get an identifier here, and then we just map yeah, we just map actually, you know what? With my newfound knowledge, maybe we could even do, we can do, what is it called? Compose. F. Actually, this would be like any type. G, any type. This would be the return type. Let's just make return type type of G. No, type of F is the usual. No, we don't return. We return a function. Yeah, we return a function that takes parameter n of type T, and I forgot what it was, if it was, oh, I think it's like any type. It's like any type if that doesn't exist. I'm pretty sure. So let's just return this, I guess. So this one would be param type of. So we're taking what G wants in the first parameter. If it's null, it should be any type. Okay, now I'm confused. I can't do this. No, not that one. Okay. Okay, anyway, let's just try this. So we take a param 0 of type of G. We return the return type of F. We return F of G of A. Hey, there we go. All right, now we can compose, hopefully, functions here. And what we want to do is we want to do this one. Instead of doing map twice, we can do compose. And the first one is string to identifier, and then we want to do, why it's not b.compose, just compose. And then to expression. to expression. It's gonna be the same as two statements, basically. To expression. Going through, we want expression. Yeah, that's basically. We can even generalize this. Okay, maybe it exists already actually. Like you take a enum or a union type and then provide and the value, which is one of the fields, and then you turn that into like this, probably to union enum or whatever. We have the comp time t, well, that's the union type, and then the value, and then we return a t, and then we just do whatever we're doing here, except this is t now. There we go. And so this is just gonna be to union t statement input, and this is gonna be okay. And then we need to allocate this as well, so it becomes an actual pointer to an expression, which is what we need. Okay. There's also the version of compose that works for monadic functions as well, or functions that operate on monadic values. And then you can like compose, let's say we compose like allocate and map, for example. That could be a function, new function that makes it into, actually I want to try that. So basically we have two allocated expression and we're gonna take a parser now, because this needs to be a monadic function, or a function that operates on monadic values. To allocated expression. Actually, you know what? We could just use bind, I guess. Well, let's just make this here. So this would return type of any type dot. Actually, this would return like return type of hang on. No, just type of I wonder if you could do that. Let's do this. Type of, and then parser dot element. So that is the child, and then we add a pointer, but we need to return this as a parser function pointer. I mean, actually, no. What am I saying? This needs to be a expression. So this is an AST expression. That's right. Okay. So now we can say, so potentially also this parser doesn't return an expression. So let's just assume that it returns a value that can be turned into an expression. So let's just also have the builder. Call it the convenience. So we'll map this to expression. So now it's an expression, and then we want to allocate. Okay, I guess this is kind of like composing this, I guess, maybe. Yeah, we're taking a parser. So basic, well, for the monadic compose, you would take two functions that operate on monadic values, like allocate and map, for example, and then compose those. But the problem here is that map takes like two functions or two things, and allocate only takes one thing. So it's a bit of a gymnastic there, but this should work. This is like easier to use. So we'll just say, okay, you can still map to that, but then we do to allocated expression like this. So we don't need to, so yeah, that cuts off a little bit. And we can also do the same thing here. Instead of doing map allocate, we can do to allocated expression b, and then this is the parser here. There we are. Oh yeah, this needs to be. Oh, this is actually okay. This is actually should be. This has to be a deferred now. So let's make this up here. So singular expression and singular expression like this. This is an expression. Yeah, it's the same thing actually. Multi-expression. All right, and then we set you. Actually, we set these things. Oops. There we are. So we're populating them at the end. They should really be like all the way down, but yeah, there we go. Okay, you are value, and no more errors. Okay. We got some issues here though. Yeah, I think number literal also. So this one now is an AST expression. We even get the nice type there as well. The number literal is not. So this one needs to be. Well, it's kind of unfair, I guess. We need like an identifier expression and not an identifier itself. An identifier. This is actually an identifier expression. And then we have the identifier is this. So this would just be identifier. Right. And this should be used here. So this is an expression. There we go. Okay, and then we have the number literal should also have its expression equivalence. So number literal expression is just to allocated expression be number literal. All right. And you are expression. There we go. All right. Okay. So now do we get infinite? No. But we get some kind of error. And 121 unreachable. Oh, I see. Let's log this out. Could not create union type name t with value, and I will just print the value out. Could not create union AST expression with value. Something literal number. Is this a tuple? Yeah, it looks like a tuple and not a thing. Okay. To union enum expression. Okay, to expression, and then no. Wait. Is that it? Where's to expression called from? Oh, it's just a mapper function. Okay. See, this is the problem when trying to debug these things. But we can see up here in the trace, we're running take one parse jar. Right, so we're done basically. And this is on line 2. So it should be an add expression and then trying to read an expression. Maybe it's the identifier or something goes wrong here. So that one should be an identifier. And do we have an expression for identifiers? In the AST, yes we have. So that one should be populated with this. Hey Lord, how's it going? So we're probably here, and then we go through, and then we have this sequence, and I would say to allocated. Okay, I see what's going on. So actually we need to map this to an add, like AST add expression thing, actually. Yeah. So this is the problem here. There's a mismatch of types here actually, which is interesting because, well, it's I mean, it's not really a mismatch of types because there's no way of setting this constraint here, except we could probably. I mean, oh yeah, okay. So we'll do this actually. Instead of making just logging here, we should do compiler error. and then could not create union or invalid value for type. You're doing all right. Great. For type for union, and then we just add a type. We add a type name here as well. Type of value. Okay. And then we don't need the unreachable because it's a compiler. So. And there we go. Now we get the actual now. Okay, because we were able to catch this error in compile time, we now get the actual error here. So invalid union for a statement literal and invalid union type, invalid value type for union main AST expression. Yeah, and that's the tuple that we saw in the thing there. Okay, so yeah, and then if we compile, we can get the trace where this is called from. 164. What are you up to, Lord? And we do 164. So this is 200 character expression, navigate map to expression parser, and then this should be called from somewhere over here. Yeah, so now we get this trace here, so in compile time, so a lot easier to debug and stuff. So yeah, so we need to map this into the thing. Set up overseer.neovim, really like it. Yeah, I think it's a incredible plugin actually. It's like, it's so, you know, it's like non-intrusive, and it's it just does what you would assume it should do basically. I think it's really nice. Okay, did we have that mapper function somewhere? To add expression, yeah, we have this one. I mean, this could really be... I mean, okay, this doesn't really turn an add, like it turns a tuple into the add. And then we have to extract which ones are the correct ones. I mean, you could try to define some sort of combinator thing to grab out, you know, the first and the second, and then combine them and do something with that. But that's just, yeah, or just have this, or just make a map here. Okay. Oh, so now let's not make it an expression. Let's make it add. Well, sure, but this is an add, and then we don't do this. There we go. Especially nice if you can set it to rerun tasks if you save a file. Yeah, I used it when I couldn't get Sig ZLS to work properly some time ago. I kind of made my own thing there where I told, like, every time I saved, it would run the compiler in Overseer and it would report the diagnostics to Zig, so I would get the compiler errors. Or I mean in NeoVim. So that was pretty nice. Zig build watch. Ah, okay. Yeah, I don't remember. Has that always existed, or I think this was in 0.13 or something. I don't remember which one I used, but I basically, the point is I used overseer to get the diagnostics from the output to see, you know, to show, like, you get the errors like this, like in NeoVim, so you can jump to them and stuff. All right, so okay, so now we got this one. This is basically probably not used right now, so where is this coming from? To statement 200 here. Okay, so a number statement gets a number literal, puts it into, so U should be a literal. Oh, I see. Now it's an expression, is that? Okay. So the number statement should basically take... Actually, we don't need a number statement anymore. What we do is we can actually just remove that. And we can just say both of these are actually like expressions. Actually, yeah, we'll make a new one called expression statement. And then that will be... that would just be to expression expression. There we go. No. What am I doing? Map to statement. There we go. And we don't need this. Okay. There we go. All right. Couldn't parse source here as well. Okay. Expected end. No, you didn't. Well, you did. This is not a assignment statement. Takes this, turns it into that, right? Okay, so this is the assignment. So first we're trying an expression, right? And then we're trying a statement. So when trying an expression, apparently that... Okay, maybe, do we have infinites? Is there an infinite here? Yeah, maybe. This might be crashing infinitely here, maybe. Let's look for that. Okay, actually, you know what? I think the problem here is that we are trying an expression statement first, which... Okay, yeah, I think the problem is in the order of things. We should probably... Yeah, let's just do this and that will solve the issue, I think. Man, I need more ban. Alright, see you. Things. I get like spam. I guess that's common. I've banned like some blanket statements for there's like bots coming in and saying, oh, you can get more viewers. So okay, so it's just quits. That's interesting. That is interesting. Maybe we'll do this. We'll keep track of. Okay. Yeah, I think it's time to put in the parser context. Like how far we've, like how deep we're currently in the current sort of parsing stack. How deep we are. If we have, for example, if we have a parser that takes another parser and calls that, that goes further down in the depth. So I will call this like parse depth stored at 0, and let's see. We should have port that should be restore as well, I think. Yeah. When we log the source, no, it should be the trace function here. Running parser. So I will add a number here somewhere like this. No, context depth. So now the number is there, and now we need to add this number whenever we have to implement this in every sort of I guess like higher order parser. So we're not using try parse actually. So let's not worry about that. Constant is not actually calling the parser. Well, actually it is calling the parser. It's calling the parser. We should increase the depth here. And then at the end, and then we defer this. So I think this should be a common, probably like a common thing. It's kind of keeping track, you know, recursive. I guess you could, if you see the whole parser concept as a one function, this is kind of like a recursive depth check of that function. Optional, yeah, that also runs anything that runs another parser basically. Deferred, bind, no, this is allocate. No, I don't think. No, this is just bind, right? Here we create a parser, but we just report directly, so that's fine. Map, that is definitely one. Bind is also that. Sequence, definitely. One off, yes. Take while. Take at least this using take while and stuff, so that should be fine. Condition, yes. Peak one is not a higher order. Take one, and let's just take 1 byte. Parse digit, parse number, parse card, string, and yeah, I think that's it. Okay, so now when we run this, we can sort of see the depth of these parts. Okay, so it wasn't that huge, but it just abruptly ends. I wonder if it has something to do with the memory, maybe. So we have the parser depth. Maybe we need even more heuristics here. Restoring snapshot to index 16. So after a yeah, it's restoring back. Maybe we should just have one that just increases every time you call a higher order. It just increases and then it's never decreased. But that just tells us like that number is just gonna go up when there's a large source code. Hang on. So what do we need? We need to know if we're in a loop, basically. How do we know if we're in a loop? I guess if we try to evaluate the exact same parser on the same in the same place, but we can't I don't think we can bookkeep that. I mean, technically, yeah, you can assign an ID to all the parsers and then have a map of source locations and check if we've run the parser at that location already. And if we have, there's gonna be maybe an error, or we try to skip that parser. Yeah, we're just gonna fail, basically. I just want to know if there is a loop, basically, here. I mean, there's a huge amount of things happening here. How many lines here? 1440. And we're... No, actually, we made past the first one. The first line. Yeah, we can see it here. We're on the last line. So statement, sequence, one-off map, sequence, parse map. You know what? Let's add more things to the labels here. Actually, whoops. Let's go to one-off, and we'll say one-off, and then we'll just put this as a list here. I'm just gonna take this as inspiration here because I don't remember. Oh, I see. So we're making, okay, so we're making a generic. So I'm gonna say like parser list formatter takes a type which should be that. So okay, so I'm explaining what I'm doing here. So basically I'm trying to print, I want to print all the parsers that comes in here as a list here. Also I could also put the type name here actually. Type name of type. Yeah, and then you have this other one. I think you have to, if you want to use a formatting function, you have to use F. I'm pretty sure. Now, yeah. So in order to print this parsers as a list, you can do this. So you can put yeah, an interpolation marker or whatever it's called here, and then F as in format, and then you can provide a formatter. You know, you can provide a formatter function basically, so something that evaluates to that. So or yeah, so what we're doing here is I want to define a function called parser list format that takes the list of parsers, puts it in a struct, which should be this struct here. And so we'll have value is t, and then we have a function called format, which the formatter, all basically print type functions in SIG has this format. So it first takes a string and then a list of arguments, but the arguments can also be a formatter. So if it's a formatter, then it would look at the format function and execute that. So we can decide how to format this with this function. Because I'm gonna reuse this, so I don't want to do this in here. I want to do it like using a formatter function, and then you also don't have to allocate anything when doing it. So also we need to catch unreachable as well. All right, so this format function. So if we go and look at, I'm just gonna do this standard JSON format. So this function is the same thing. So it takes a value and then also options, and then returns a formatter, and then it just sets, you know, it just creates this struct. And the point is that this has a function called format. So I should copy this and go back here. And now this is my format function. So we'll take self this writer, and it can be an error, a return, a void. So basically, yeah, so you're writing into this writer, and this works for any, you know, any data, whatever destination, and yeah, it's just a very generic way of formatting strings here. So now we just need to use this writer to write this data. And what's nice when you have a writer is you can just you can just do this. So you can do an inline for fields of t, and since we want to write a list, first I want to write one of these, and then I want to write at the end, I want to write that. Okay, and then in the middle I want to write no, I want to print, and now you can do s, and then the value is going to be field of self.value and field of name. So that now this, we know this is a parser, so we can just access label directly here. So we'll print the label, and we can also check here. We can get the index if index is let's say less than the length of the fields minus 1, then we want to print a comma for the next one as well. Yeah, so if I is like, if it's not the last item, okay, we can also do like not equals. If I is not equal to the last item, we will print with a comma. But if we don't have any more items, we have only one item, we're gonna print that. And if there's no items, then it's not gonna go in here anyway. Okay. So now we have that formatter. So now we also need, we need a function here, parser list format, that takes the parsers and the type, and we return this formatter with type of parsers, and we just return value equals parsers, and we can just rename that because that's the only thing we're working with. Okay, cool. So now the one-offs should show the type, and then the parsers that are within. Okay, we've got 3 arguments, found 2. Oh yeah, you need the allocator as well. That's right. There we go. And you always need to try these. There we go. All right. No? Got some issues. Tuple or struct? 5, 3, 4. Oh, I see. Yeah, so this needs to be a tuple here. There we go. Okay, now it's a little bit different. Let's see. Do we have any one-off? Here we go. So here you can see now one-off, and then it's like, yeah, we want, it's gonna return a U8. Actually, that could be very good to see what the actual result is on everyone actually. Trace, no, log tracing. So running parser, and I'm gonna add the type name here. Oh yeah, we have the type name. It's gonna be type name T. There we go. Oh, sorry. Whoops. This needs to be over here. Type name T. There we go. All right. Now we can see for every one of these what the actual result is supposed to be. So that's good information. As well. So what is happening here? Yeah, so the first, it should be trying to, yeah, it gets past these ones. Good. Then we are at this one. I might be able to like collapse some of these logs. Like if it's just a, I don't know, if it's just a map or something, maybe we can like collapse it so we don't get this huge list of things. We'll see. Deferred at source. Yeah, this is the deferred. This is the expression. So we're trying to read an expression. But why are we trying to read an expression? I thought we started with an assignment. Because this is the first new line. Wait, no, it's not. Actually. I see, here's the first new line. Or, yeah, here's the first on line 3. Yeah, first we try the statement. Yeah, maybe we should have like the breadcrumbs. Maybe we can have breadcrumbs. Actually, let's make this into an array list of strings. Then whenever we change the depth, also the bread. Okay, so how do we restore the breadcrumbs? Good question. Now the snapshot is not merely, you can't just copy it like this. We also we need the breadcrumbs to be clone. Okay, yeah, we can do breadcrumbs clone. There we go. And so when we restore, I think we also invalidate this snapshot. So basically we will do breadcrumbs deinitialize, and then we will set you to snapshot breadcrumbs. We'll just take this over here. There we go. Okay. Now, log let's now log and we can I mean, I think we just log it as it is. Probably. Actually, you know what? Let's just use like a JSON formatter. Actually, no, JSON format. Value is gonna be the breadcrumbs dot items, and yeah, that's fine. White space is minified. Yeah, we only have one array, so that should be fine. Okay, so we got that. Now we should get a whole bunch of these empty arrays, but now we need to modify it. So basically, anytime we're doing anything with parse depth, we should also add our little label here. The question is what we should have here. So breadcrumbs append and excuse me. Type. Okay. First off, yeah, we need the string as well. So this is gonna be breadcrumb. Okay, so what is going to be in here is going to be, it is going to be, actually I would like to add a function actually for this in here that is like add parse depth, and we just need the string and the arguments. Now basically do all this. Except this is format, this is args. Come on. There we go. Alright. Now let's go back here and we'll do context, add depth. Okay. That's way easier. So here we can say, well, what is this? This is a map. So let's just do this and then map. Actually, map so parser, so this is type name of A and type name of B. Thought we had a, no, this is constant. Oh, I see. Wait, but this is, oh, so this is wrong. Okay. Actually, let's just use format or JSON here, actually. Okay, so this is not map, this is constant. And yeah, it's just B. There we go. Cool. Now let's do it for the other one. So parse depth equals 1, and this one is optional, type name T, this is deferred, here we go, here's map. Type B, map A to B. This bind A, yeah, to get parser elements. Actually, let's just do that. Oops, daisies. Oh, come on. Sequence. Now sequence doesn't really produce a type. Actually, it does produce a type. But do I really wanna put the entire thing here? I'll put this off for now here. One off. This does have a type though. This does have a type, so type. Oh. How did that happen? Type name of T. Take while is also type name T. Condition. There we go. Holy shit. Okay, so here we can see the entire trace of parsers, basically. And so if we go up to where we we get a whole bunch more lines now. But basically, okay, let's see if we can find at one, no, 3, 1. Here's the first one for 3, 1. Oh, okay. So we're actually never decreasing breadcrumbs. Also, another thing which is stupid that I realized is that when we defer here, yeah, we need a, that doesn't work because it's gonna just lower it at the end of this, which is not what we would need. So we need to do remove parse depth. Let's actually call this inc parse depth, and this is dec parse depth. Proper programming terms or lingo here. Parse the context. Yeah, that's all we need. Okay, now we will do this, and we also say so we can get last, and I want to free that. So we'll free the last just to get something back. And then actually I think we have to do it the other way around. So we get the last just to make sure that maybe the order is in the correct like allocation order that we free it. If you free it in the reverse order that you allocate, you might be able to get that allocation back without running out of memory. Okay, and then we'll free that later. And before we free that, we want actually it doesn't matter actually because it's not gonna deallocate this anyway now. Okay, well, whatever. Then we say pop. We could just do this, actually. Or else return. Okay. Okay, this is the first one. Oh yeah, okay. And now we also need to call this everywhere. So we need to go in here, we need to defer, context inject, parse depth. Oops. There we go. Okay, now we don't get nearly as many places. And now when we see here we start, we're saying running parser. I would expect this to be just one element. Statement. Map. This to main AST statement, and then a sequence take while map. Statement to state. No. Okay, I'm confused. Okay, well actually I know that we're in we're currently in okay, so if we go back here and see what we're actually reading here. So the parser starts here, okay. We have my parser. Then we have first and then sequence. So this is the actual like first parser, I believe, that will show up here, I think. Yeah, sequence. This is the sequence, so that's the main parser. So the first one here is a map. Oh, that's the first. Oh, that's first. Okay. Right. Okay, maybe we should implement some collapsing here. So how would we do that? So we have first. So how? So we could maybe... We'll set the breadcrumb. And that's the same as like add label. let's do this just for convenience right now. I'm probably gonna change so label is the actual breadcrumb anyway. This one, yeah, so it's just gonna be basically this set breadcrumb. This will be breadcrumb is equal to that. So basically the same thing as label, except we're changing breadcrumb instead. Okay, and then first we want to say, okay, so now when we have this breadcrumb, I think instead of like when we do like add parser depth or ink parser depth, parse depth, I actually don't think we need to say anything here. We just pass in maybe this, because that's the parser. Or no, we need to pass in self. But this function doesn't even take self. Ooh. Do we need to change the parser interface? We could also, when we run the parser, maybe also increase the depth. Like, how would that work? Like, when we do run. Yeah, I mean, this should probably just be called here. And then this is that. Yeah. Yeah, and now everything needs breadcrumbs, so let's do that. Constant. So basically taking this, what's in here, and putting it in the breadcrumb. So what I will do is I will do this, search for ink parse depth. Remove that, go back for label, add a new one called breadcrumb, paste, join, we'll remove that, and that, and that. And we'll add format alloc print, self allocator, that catch and reachable. Okay. One off. All right. Type of no, yeah, type name. Okay. What did we get now? Integer overflow. What? Okay, but let's look here now. We got map struct. Yeah, so that's now the, okay. So what we want to do is we want to go to first, and we're gonna say set breadcrumb. And we're gonna say first, and then what type it produces, which is gonna be this type here. Oops. And type the name of that. There we go. Actually say this now. Type name of T. Okay, and now if we go to the first one, now we see first here instead. Okay, cool. Hello, Blue. How's it going? Let me just refill my glass of water. How are you doing, Blue? Right, so now we can kind of more easily look at what we're doing here, probably. So we get first, and then we have a sequence. Okay, so let's see if we can. So this sequence. Let's do like set breadcrumb. I would just call you statements. Actually, maybe we could also say that this is not supposed to be in the breadcrumbs. Well, whatever. So now we can see we have first, and then we have statements. And then we have take while statement. Take while. Take while statement. This one. Yeah, we're adding label. Let's just set the breadcrumbs instead. You're doing okay. I figured out the purpose of life is to program in Zig. Making parsers in Zig. Take while and reading a statement and so on. Okay. And so on and so forth. Let's see where the issue is. Okay, there maybe there's something wrong with the restore, like because when like for example, we have this one-off. Now the idea here is that you pass in a bunch of parsers, one of them, the first one that succeeds is going to be the one that's going to produce the value. And so that means that oftentimes things fail along the way. So if you have a one-off somewhere in here, I guess anytime you want to roll back basically, because that's what we're doing here. So we are taking a snapshot before we run the parser. We take a snapshot of it and we restore it if there was an error, which will roll back to that point. Now this one is complaining. This one is like take one. But before that we are running condition. And the condition, I mean, that just reports an error if the condition failed. Oh, we keep these. Oh, I never removed these ones. That explains a lot. Yeah, we have to remove these ones. We changed how we how that worked there. Okay, there we go. This is only called once, and this is only called once. Okay, cool. Or for one place. There we go. Okay, now we're back to where we were here. But we have, dare I say, better debugging, or we're working on the debug messages here. So here's the first parsing of the 3.1. So first, we still get this. Oh, this is the sequence. Okay, so it's the sequence of statement and then an optional byte. Right, that's the end line, I think. I would like to learn how to parse a PDF. I think there should be plenty of resources for that. I think I've heard that it's not really. It's kind of a daunting thing, but I think there should be plenty of resources on that. It's a really old format. First statement, take while, statement, sequence. Right. Statement and then sequence. What about right, so we are probably in this sequence here. Actually, yeah, I can see how this like what is the difference? Let's say we run I see. So I think basically now we kind of skip. Yeah, okay, the breadcrumbs do not match up now. That's the problem. They don't really match up because, yeah, here we got like statement and then sequence. Okay, well, what sequence are we talking about? Because we have the statement is this one, but we have a first here, and the first is not stated here, but we have a sequence, so I presume it's this sequence. Because the first is gonna run this sequence. So yeah, when you run this map, it's actually not putting its own breadcrumb in there. It's just running this, and the breadcrumb of the inner parser is gonna be put in the breadcrumb instead. So that is not entirely correct to put the breadcrumb, yeah. So I think we have to move it out actually. And put it back in each one of these. Alright, let's just do it. I mean, it's just gonna be this basically. Except the problem is that we don't have self. That's the problem. That is the problem. But we could easily fix that though. Actually, I mean, we could just go here and say that the first argument is the parser function itself. Yeah, just this. Then when we run it, we pass self. This is kind of weird. We're calling self parser, but that's a pointer function, and then we pass self. I guess if the compiler says it's okay, it should be okay. Okay. Now this is a self. Okay, I'll call it P for parser. And no, that's not true. This is not true. This is a parser function. Yeah, you have to do this. Because this refers to this struct, which is not correct. Okay, and then yeah, and so then I'm just gonna make a convenience function here for inc parse step, where we take self and context. Maybe there's a library for that, but I would like to learn. I mean, yeah, probably is a library for that. But yeah, that's the, you know, a lot of things I would recommend, like building something yourself, because then you get a really good grasp on how it actually works. And then the next time you want to use, maybe you want to use a library for convenience, but it's I would say it's like really good to learn. You know. You don't need, I'm just gonna do that. And I think what we wanna do is perhaps, I think all of these should have its own parser. So what we're gonna do is I'm gonna find our function parser underscore. I'm gonna go to start of the arguments, and I'm gonna add p, comma, and then we're gonna go back to dot parser equals struct, and then actually we need to go to self create parser, and then we'll go to the next one, and then we'll go to the next. Anything. And we will grab until the next thing there. Copy that. Can you use Ctrl O, Ctrl I in macros? Actually, we don't need. I'm just gonna go to parser equals struct, And then I'm gonna go to function parser. I'm gonna go to P, and I'm gonna add that, and then we're done. Oops, oh, I added. This isn't used, so that's why this is okay. And this is the same thing, yeah. Okay. Now I've got a whole bunch of unused, and yeah. So what we want to use this for is we want to wait. Why do you? Oh. Right. So what we're gonna use this for is we want to say now. Ink parser depth, defer, decrease parser depth. There we go. So we want to do this one on every one of these. That is a higher order one. So this one we don't need. So we can. That this one we should have it. Whoops. There. I mean, for sequence, actually, we could even say which one we were in, I guess. Well, I guess we get that from the breadcrumbs anyway. This is one off, yes, yes, yes. This one doesn't care. There we go. Okay. Where are we now? First statement, take while statement, and take while statement sequence. What the hell? Still get this. Let's think about it. So first we have first, then we have sequence, we have one off. Now this whole thing is a statement, right? Statement. But then we should have first. No, but it's running the yeah. So map. Hmm. This should be run. And then we're increasing the depth here, we're decreasing at the end. We run it. We map it, we return. The inner one is the sequence. And if we label this sequence, let's say set breadcrumb statement sequence, or just and then run. Yeah. So this is where I'm confused. Actually no, okay. Hang on. The first uses map and sets breadcrumb on the map. Map returns a parser with a breadcrumb that we write over to first. That and yeah, so my question basically is that why is this? Oh, I'm stupid. Okay, I'm stupid. We're setting the breadcrumb of the first here to statement. Okay, man. Okay, okay. That's why we don't see it. Wow. Okay. Never mind. I was like, what the hell is going on? Okay, yeah, that's the statement that we see there. And then we have the sequence. And then we have the one-off statement, right? Right. So so now the question still is why is this why why it says can't parse the source, and we're going through. Let's just go to 3.1 to start here. Right, so it shouldn't so this is not a statement. This, or I mean, it is a statement, but this is not a assignment. And if we look at our whole parser here, we have either an assignment statement or an expression statement. So when we start here on this line, this should be evaluated to an add expression here. And then in the add expression, we're also gonna evaluate the second part here as an expression, which will itself be an add expression, and then we should be done with those expressions there. Because we have a thing there, yes, which is part of the statement. So this will become an expression statement. So that's what we would expect. So first it goes through the assignment statement test. Can we actually see that somewhere here? I think we should probably label things a little bit more here. So here's an expression statement, so let's label that. Okay, and then this one is assignment statement. This one is identifier. This should be to this. Add expression. Maybe I don't need it for everything, but number, literal, expression, yeah, sure, whatever. Number, literal, we could change. Keep the the names short so that there's not too much going on in the logs. Expression singer. Yeah, these we could set the breadcrumbs as well. Oops. Yeah. Expression. Singular expression. I call it one expression. And star expression. Okay. Add expression, singular expression method, yes. assignment statement, inspection statement, parser. Let's just call this statement. Get rid of the parser suffix on these things. All right. Okay. Let's go through this again. So we have all these statements, stuff, sequence, one-off statements, assignment statement. So it's checking now assignment statement. Maybe we should have like whenever a statement fails, we should like, instead of just restoring and going back, if tracing is enabled, we should log that as well, maybe. So basically, like, for example, in one-off, when this fails, we restore and add the error. We should also, if where is this? Builder, I think. Builder is tracing enabled. Log fail, log like failed or like discarded or something, or what would you call this? Like you try one thing but it doesn't necessarily mean that it's an error. Unless we get to the end, in which case if everyone was an error, then this whole thing is an error. I'm just gonna say one-off discarded. This, and then that should be, yeah, I'll just put this there, that's fine. Like whenever we do restore, what was this one? Take while. We could also say like take while stopped. Is that the only one? Okay. Oops. Okay. Take while stopped. One-off discarded. Take while alpha. Yeah, it should stop like immediately. Yeah. And then one-off discarded. Then I guess it tries the next one. What is this one-off here? One-off here. Expressions. Wait, did we already fail the statements? Hang on. The assignment statement. The first one should be an identifier, yes. Which is just take at least one alpha and string to identifier, yes. This should be type name T. When are we gonna add potatoes in the breadcrumbs? That's the next update. Okay. Okay, so what are we doing here? We're still on one of expression statement. Okay, so now we're on expressions. Add expression, right? So we are on the add expression. And this one should be, now it should be like on the string, right? This should be like, hang on, is this the problem here? So first we read, okay, where are we? Numeric literal. We're reading a numeric literal right now. Maybe we should only show the breadcrumbs that have been like explicitly set to make this a bit easier. I know I'm going back and forth a lot. Okay, let's just continue here to see. But I really no, let's do it. Let's we can have several, we can have different levels. We can have like tracing level insane. So we'll have like breadcrumbs that are the insane breadcrumbs. Actually, you know what? Let's do this. Let's do this. Let's say that breadcrumb is breadcrumb. Let's say that this is optional, and when we log, let's see, yeah, if we increase the depth, we will say I think we only do it if we have a breadcrumb. And same thing here. If this is null, we don't do this. Okay. So now basically everywhere we do this, we actually remove these now. Maybe, or we set the label. Actually, yeah, let's set the label instead, because that's a better label, I think. Let's just change this. Oops. You said your PC adapter stopped working. Ah, that's shitty. Bad computer. Let's just make a macro here. Breadcrumb. Let's just do that. Go to label and delete that. And missing. Let's set it to null. There we go. All right. Assignment statement failed here. Take at least. So this one, take at least. I don't really want to set the breadcrumb down for that. I just want to set the label. Yeah, I don't think we ever want to do this anymore. Let's just, if we set the label, we're gonna do add label instead. There we go. Take while. Why do you have? Wait, why are you not? There we go. Okay, statement. Yeah, I guess we get the actual the long thing here, and then we get the breadcrumbs that we're interested in maybe here. Okay, identifier alpha that failed. And now we're all back to statements. So now we're trying to read an expression statement. And we're trying to read an expression. And we're trying to read a multi-expression. And then add expression is trying to be read here. A singular expression. Identifier should fail. So now it should be like a one-off identifier or literal. Alpha should fail. There we go. Now we're trying to read a number literal, and that should succeed. We're consuming. Ah, I see. No, wait. Number literal. This should succeed now. Should we also log when they succeed, maybe? Yeah, because now it should have like a number literal. And read the string as part of the add statement or add expression, which it's doing here. So we're reading that string. Okay, cool. And then we should go the same thing here, reading and reading that. And then somewhere along the way something goes wrong. It goes back all the way to the start. So what is happening here? We're still on the add expression. Is it the restore that's wrong? It's like restoring all the way to the all the way back to the start, but it should really. Now here is running parser. Take one. What's happening here? Are you making an AST? Yes. A capacitor blew up and I changed it, then a diode blew up. Are you repairing your own adapter? Are you an electrician? Yeah, so I'm basically, so I'm making a parser, and you know, now I'm just making a tiny, you know, toy language to test the parser out. And I mean, it could be a problem with the parser, it could be a problem with right now with the with my parser, with my like setup here for this language. But then I'm also like, when I'm encountering these problems, I try to improve the debugging so that you can debug what's going wrong. So now we have this add expression, this. So we have a sequence. So we have singular expression. We parse this string. So the singular expression is either an identifier or a number. And then we parse this. So it's very you know, rigid right now. You have to have space plus space, and then the other thing to have a correct program here. But then you have another expression, which could be either another add expression, so you can chain the add expressions, or you can have identifier or number. So first we're trying the larger one, the add expression, and if that fails, It should go on and try identify a number. So now we should get a number literal. If we have like, so basically, like if we look at the source code here, these two actually work. Like if we remove this, we should get a functioning program here. Here you can see we got like, okay, so I think last time we tried to implement the variables, and now we actually have variables. So we have x equals 4, 3 plus x is 7, so that works. And then if we now we can, I think we can even reassign this now to 10, and then we say 5 plus x, or x plus 5, just to make it fun. Then we can see that first x is 4, then 3 is 7, or I mean 3 plus x is 7, because x is 4. Now we reassign x to 10. They assign you can see here, sorry, voice crack. You can see here that the x, the assignment expression also yields some like a result as well. And then x plus 5, since x is 10 now, it should be 15. So that all works. The thing where it breaks down is when you have a chained add like this, and now all of a sudden there's a huge problem here, where we get this infinite loop or something here. So there's a lot of things going on. So it basically goes back to the start again to try something, I don't know. It breaks here, and then it goes back, and now it's trying to parse an expression, a singular expression. Okay, which it should proceed to succeed at. Hang on. Expression statement. One expression that should fail, or one expression should succeed, but expression statement should fail because there's no semicolon after. You're not a professional electrician, just overconfident. Okay. How old is your capacitor? Or I mean, capacitor. How old is your adapter? I had, like, when I was younger, I had an adapter that was full of, or is it called adapter? Like the you know, the, we call it in Sweden, we call it like nätagg, like yeah, it's just a power supply, the power supply of the computer. So I had like a power supply, and it was basically, you know, I had it for years and years, and then one time the lightning struck and the power went off, and I saw like a blue flash or something, and like in the computer, and then it just was dead after that, the power supply. I tried to make it work, and what I did was I noticed that it was basically packed full of dust. So I open it up, and yeah, it's the device that, you know, you plug in to the power supply from the wall, and then you have all the, you know, connections to the graphics card, all the power connections that comes out of it that goes to the graphics card and everything else, like the motherboard. Yeah, and so I opened up the box of it, like, yeah, and it was basically everywhere where it wasn't circuitry, there was packed full with dust. So I cleaned that up, but then, you know, I couldn't get it to start again. It makes sense. yeah, I don't really have that problem anymore. But I realized that it's probably good to like, you know, clean the computer from dust from time to time. Hello, Lord. Welcome back. All right. 1 second, I'm just gonna fetch something here. When there's a fluctuation in voltage, it just stops. Happens to me too. Okay. Yeah, I don't know if the dust was part of the problem, if there was like getting into the wrong place, or I don't know. Like acting as a conductor or something. I don't know. Maybe it doesn't. Maybe it's just for heat. It like increases heat of the components. At least. Oh, your laptop is fine. It's just a data charger. Oh, it's a laptop. Okay. Oh yeah. What are you doing, Lord? All right. Okay. Is what's happening here that we're logging too much and it just doesn't flash it, or it just doesn't flush it out in time, like it exits before it flushes everything out? What is happening here? Because it's like sometimes we don't get the whole thing. It could be the capture of, I don't know. But it basically says here that we expected an end here because it couldn't parse the... So this is kind of a weird message because, yeah, we were actually reading a plus. So this could be the place where we would try to implement so we get a better error message, because this error message doesn't make any sense. We have an add expression. We would expect the error message to be somewhere over here, maybe, if it had trouble parsing this. So we would probably want to have like take all the errors that went along the way, figure out which errors, depending on some heuristic, probably went into the index like deepest, and display that error. A chili on Sunday, yeah. Late breakfast. Nice. Does do overheat, but not short circuit. Okay. Well, that answers that. I'm from Sweden, yes. So actually, I think after you run a parser, you should always like add the errors here. We have an error list, and then when we display the error, we should just show the error that is like deepest in the source. Reminds me of PewDiePie is learning programming too. What? I saw him. Yeah. Okay. I don't watch him too much anymore, but I saw there was one video which was interesting where he was talking about Linux. But I mean, it was mostly how to like change the appearance. But I mean, it's interesting. I mean, I'm not really into that stuff, but okay, so he's learning programming. Is that true? Okay. It's Halloween, so I have it has been Halloween, so I have a bunch of candy here that needs to be taken care of. What? Oh yeah, how was your Halloween, by the way? Okay, well, first off, we need to make sure that all the errors are reported. So let's go to these things. So I think we have like one off. It's just finding this restore actually. So here we're adding things to the error and then reporting if everything failed. But I think these errors should still be reported even if there's a success. Maybe? Because there might be a failure later. Man, I don't know, man. It's like stuck on this. Let's change the program. Let's just have this. And then it comes to the end. Oh, it goes back. What's happened here? Parser dot? What? Oh, that's the one of that. Okay, so we're still on the number, I see. Yeah. Digit. So there should be no digit. We discard that. Now we're trying the dot. That should be discarded. Now we are trying something else. A space. Okay, we're trying another add. But that fails. Why are we going back to the two? Oh, we tried to do a multi-expression. I see. So now we're doing a singular expression and we should go back. Now we're trying we're still reading the number, and we realized that we failed. Now we're reading a parse. Now we're reading a semicolon, and we successfully did that. Now it should read. Why is it trying this again? Is that the problem? Okay, well, first of all, I want to fix this error message here. So, yeah, that's the thing. It's like it fails the one of. I'm not sure if we should add them as the errors if we succeeded. I don't think we should do that, but we add them here. And so here we're reporting the errors. We said it's learning in the last video about AI labs. So vibe coding. It does have a GitHub account, okay. I mean, you don't have to be a programmer to have a GitHub account. You can have your configs and I don't know, stuff there, I guess. Lord, I'm somewhat annoyed that you handle out of memory as unreachable. It's just a habit now that I do. I do it because yeah, it's like a habit I gained by using a library that did it. Because it's basically the idea is that if you're out of memory, then you're basically screwed anyway. So, but you know, then you might want to have some sort of safe exit. So it's kind of bad, but for the intents and purposes of the other program, well, I guess it's always bad to crash. You want to have some safe exit. Hello, Con. How's it going? I really want to write parser, but I fear even starting. Yeah, that's the thing. I mean, the more you do it, the better you will get at it, and the further you will get. I try to do it like learning by doing, and then learning like that. But and then mixing a little bit of theory if I get super stuck or if I just have no idea. But I also basically took ideas from other libraries that I've used. When it's incorrect, unreachable means there is absolutely no way this can happen. Unreachable is a compiler hint in release mode, so if your program runs out of memory in a release build won't necessarily crash, it will invoke undefined behavior. Oh, I see. If you want to crash, which I would never do in the library, by the way, you should use something like panic. I see. Yeah, that makes sense. That does make sense. Well, I think the undefined behavior will be either you have some yeah, it's just gonna be a seg fault most of the time, right? Probably. I wonder. Yeah, I should make that into a try, but yeah. And then you get out and you might like safely exit somehow. Let's see. Actually, you might be able to maybe you can do like a wrapper, like a allocator. a fake allocator, a wrapper or something that will take care of that. That will first check, okay, do we get an out of memory error? If we do, then we do the panic. Otherwise, it's it's not unreachable. We return the results. But then it says it's like, yeah, we can throw the error, but it's not thrown error. Allocator wrappers that panic on out of memory are an established concept. That's what QBs does, for example. Okay. I don't know what that is. So then that works. QBs is a Minecraft clone in Zig. Ah, cool. All right. But you do have memory allocation in what is it C++ you were using, Con? Yeah, this just gets one of these messages. It's like every time we get an error, we should add it unless it's expected. Like here. We should actually add these errors. But I don't think we should add this one. Because it could succeed, which means this whole thing succeeds. Actually, it could succeed and then fail and then go back. Try another one, which fails a little bit before, but then if another one succeeds, no, but then it doesn't. Okay, then it doesn't succeed. Any one of them succeeds. This bails out. One of. So it can be part of a chain as well. If it fails further in but then succeeds in another one, and then goes out of the chain, tries another one, which sucks. No, but then we don't try another one. We have succeeded. Succeeded. Okay. There's gonna be a war here in the comments. C++ says you find a callbacks invoked when you're out of memory. Oh. Zig will always feel gibberish. regardless. How can any language... Okay, well, to be honest, to be fair, Con, I think you have way more experience with C++ than with Zig. So it's not... I don't think it's fair to compare. Have you tried programming in Forth? Or what is it called? Brain dead? I mean, not every language can look like exactly like C++ or C. Then it wouldn't be a new language, basically. All right. I'm just trying to figure out, like, I'm trying to think about these errors. I think we just want to report every time there's an error, right? So when we do run, now, but we could have like hidden errors here. That's the problem. Man. Yeah. Because if you have a one-off with some options, we have one of them succeeds way down and then fails at the end. Then we try another one which succeeds, or it just fails straight away. And then a third one that succeeds somewhere else. Then the whole thing will be a success, right? But then you go out into an outer scope, which might also be a one-off, and that one succeeds, but then it goes out again because it succeeded. No, but it could be a part of a sequence. Yes, a sequence that succeeds, but then the next thing in the sequence fails. Right. And then that whole sequence fails. But the error in the sequence could... Yeah, the error... Yeah, okay, so every error needs to be reported. Okay. You should add something with channel points. I have like 2,000. I don't know what that is. Sorry. Is it a Twitch thing? Channel points. I'm just programming here, man. 2,000 points. 2,002K. What do you mean? I don't understand. All right. As a note, SIG parser error reporting code is in stud under stud SIG error bundle. Use that in parser. Oh, cool. String extra. Okay. Location. Yeah, look into that. For now, I just okay. So this error needs to be reported. So we actually, even as we succeed, these potential errors need to be reported. So I will just add that. Or is this an... Yeah. And then the errors of this one-off. Yeah, fine. But this potentially will be duplications now. Maybe, okay. Okay, let's just do this. When we succeed, it's fine. Take while. This could also be an error, but take while is kind of special because it can be like 0 or more. It's kind of weird like that. Let's not worry about that. Because even if this is an error, we have a success. But I mean, that's the same for one-off, I guess. Anyway, whatever. Let's not worry about that. Let's go condition. I think it's basically anytime we do a restore, we're gonna have special case. Or actually, anytime we do run and the result is error. No, but they could be hidden errors. That's the whole thing, yeah. That's not hidden. this is hidden when we report it. This is not hidden. Okay. Then, okay, so when we run, we will get the result. We switch on it, and if now we should get like 1,000,000 errors. And then we'll do, we will take here and I will say min or max error we will loop through the errors and we will find the index is more than this, or if we have that, and this is more, actually, if we don't have it, we set it to error, and then here, and then we continue, and here we will check if it's more. If it is, you are now error, and then here we have the max error. So if max error catch return, sure. You want to start with a standard SIG error bundle work in progress, which you can add errors to. When you're done, you can turn it into an error bundle. Works now. Ah, cool. I'll see if we can adapt this later to that. Thanks for that information. Max error. We assume that we have one. There we go. Okay. Now we get some error that is like the furthest ahead, instead of getting, you know, the last error message that was reported. Okay, I'm not sure if this helps to solve this issue, but I think it's at least a bit nicer to see, you know, the furthest you could go. Yeah, and sometimes you don't get anything. Right, so it's trying to read a number literal. Here it fails to do that, so it goes back. And now it's reading that, which it consumes. But here's a weird thing. I think the problem is we're doing a double semicolon. Because here we're reading, we're parsing this, we're consuming that. Next time we're still consuming this. So that's so somewhere we are consuming 2 semicolons is the issue. Okay, we finally got it to a state where we could see more of what's actually going on here. Cool. Okay, this one is done, basically. Not really. We have to sort of figure out a better solution here, I think. But okay. So basically, maybe we want assignment statement. This is read as a part of statements. Now, crucially, at the end of statement, we have a semicolon, expression statement. Does not have a semicolon. So two statements. Two statement parser. I think we'll make this so that the parser we take in is gonna become a statement parser if there is a statement parser that we can bring it to. Like if the type of this, like if the result type of this parser is if you can do 2 statements on it, then we make it into a statement parser. So we'll return a map to statement on this parser. And then we also add the semicolon at the end. Parse char semicolon. Right, so now we have this whole thing. So we can go to our assignment statement. So actually, yeah, if we could make this, we're making this into a statement. We could make it into just this part, which is assignment. And then we will make you into two statement parser. which will make this whole thing into a parser. And then we remove this. So basically, yeah, we're reading these things. Identifier equals something, and we map that into an assignment, and then the statement parser will add the semicolon at the end, and also turn this into a statement automatically. Hello, Pie Trader Detective. How's it going? Welcome. And then we should do the same thing here. So we'll do to statement parser. So now this one should include the semicolon. I mean, you can also add the semicolon here, but I guess as well. But or you could actually, what you could do, no, because this has to result in one type. I was thinking like if you could take any one of these and then turn everything into a statement parser, but then this type has to be the same. So yeah. Anyway, now these ones are statement parsers with both have semicolon. But why? But the problem is was that we had like 2 semicolon parsers. Add expression. Oh, this is the problem. Okay, here's the bug. The expression will never have a semicolon. This should not be part of the expression. There we go. Oh yeah. I need to wrap you in a tuple. You've been building parser and zig, but yours more imperative, mine is functional declared. Yeah. Oh, cool. How's it going with your parser then? Let's see, compiler event. Oh yeah, so one of these. Let's see, where is this? You should be fine. Expression statement. I see. So now we don't need to map this to, because that's happening in that one. Yeah. So this maps the thing to a statement node. Yeah. Takes care of everything there. To statement parser expected statement. Oh, I see. Okay, yeah. So we need to wrap it in a first to grab the first out of this sequence. There we go. Hello, Polaris. Thank you. Have a nice day. Welcome back. Okay, we got some errors. Type mismatch. Expected that found something else. Okay, so it found an extra byte at the end. I think it's, where is it? Here, yeah. There we go. And you can check the compiler trace to the compiler logs to see where this comes from. I don't have the diagnostics show up in the editor, but you can check the stack because I think when you get like in Zig, like when you get compiler errors like this, like when you get like these manuals placed compiler errors, I feel like it should be well, you do get these called from here or whatever. Where is this? Type mismatch. So here's the actual error. And then reference by. Wait, I thought you had like this called from here or whatever it was called. Yeah, anyway, the problem is that you would want the error not to show up at this place. Well, you want this here as well, I guess. But you would probably want it to where you call the function as well. Because that's the actual, that's where, you know, where you should fix the problem. But this one also has the same issue. So there's probably, I have a function somewhere, a mapper function that has the wrong type or something here. Yeah, here. There we go. There we go. And now it succeeds. Woohoo! So where's the source code? Here. Okay, so now we can add, you know, whatever. As long as we adhere to the number or expression here, space plus space, and then the next one, space plus space. Oh, except this didn't work. It's a runtime. Index out of bounds. What? Zig version is very under development while a prototype in Franken C, my custom C. Okay. Cool. Is done for its simple functionality at the moment. Okay. I'm porting the C version of the parser to Zig. I see. Is it your first endeavor into Zig, or let's see, 157. Index out of bounds. Oh yeah. This is a problem with functional, like this type of thing. Like sometimes you have to dig where the problem is, because you get the, well, why are we getting it here? Index out of bounds. 157. No. Root. Here we go. There we go. Here it is. 30, length 30. Okay, so I want to add the length of this. There we go. There we go. Because it was, the buffer was too small. I'm doing some weird string shenanigans here. Is that correct? Let's make sure this is correct. I'm gonna copy this, open up this, Okay, that works. Why is it removing the 0.05? So every number is read as a F32. Here. In my language. So I'm not sure why. Let's do this. Let's add, whenever something succeeds, I want to log what the result was. I'm just gonna JSON parse it, JSON format it. So the string will be self label, and this will be JSON format. We get the value here. There we go. Oh, I see. This needs to be F. Unable to stringify type void. Oh. And type of T, or yeah, and T is not equal to void, I guess. There we go. Okay, well, it's kind of hard to see what's going on because it's not showing everything. What if we... Okay, so I'm gonna disable this one and only keep the other one. Success, okay. Course number succeeded with. So we got 1 5 2 5 1 2 3 4 1 2 4. Okay, well that seems correct, but then when it's added, okay. I mean, what if we just log? Now this would, but this would be in runtime though, or compile time. I mean. Okay, that's a fun challenge, Blue. I think I can, actually. I've been writing Zig for a year and a half, more or less. I've been hacking some simple stuff, Zig version of LS, fine, and cat promise. Okay, cool.
I'm just gonna... Okay, so we'll leave this. This is like a precision weird thing. I think what I will do is maybe do this. And... actually, let's find this. And... do that. But this won't work because these are constants. Like we could maybe... What if we make them mutable? And then we log... I mean, I should have just made an array. Actually, maybe it's enough to say that it's a F32. Yeah. Right, and then we change it down here. So we add one, we remove, we log it, and then we remove. And then here we will do reduce, add a. No, wait. There we go. The party part has been learning about Zig, but first make a prototype, see if I couldn't figure it right away in Zig. Okay. When I couldn't figure out IO in Zig, I ended up writing C first and port it to Zig. Oh, I see. Cool. Yeah, see? It's like Zig. Yeah, so this... okay, I just wanted to confirm that there was nothing wrong with the parser part. What if you make these F32s? Yeah, it's still... Okay, whoa, that's even weirder. 1.25? Okay, whatever. Okay, I just wanted to confirm there was nothing wrong with the parser itself. Okay, cool. But you can have statements like this now. Great. And we can set x to that. Can we do that? Actually, we can't because we don't. Okay, so I'm just gonna confirm we can't do this. Expected digit, yes. So if we then go to the assignment statement, and you can see here we only allow number literals, but actually this should be an expression, and now it should work. Question mark. Oh wait, yeah, okay. Now we change this into an expression, and the value is now the expression, and now we need to change u to allow for an expression instead. And I mean, it should be the same thing here, to be honest. Okay, still have a mismatch. Oh yeah, this needs to be a pointer, that's right. And you are a pointer, there we go. There we go. Okay, cool. So x equals that, and then we can, where's our source code? Okay, cool. And then we can say, you know, just x should work. Yeah, x plus 5. Yeah. Now we get too much logging here, so let's disable the tracing. Where is that? Yeah. What's all this? Why are we running? Where is this coming from? Oh, there we go. I previously set it to be something else there. Okay, plus 5 or negative. Oh, I don't have. Oh, so we don't have subtraction. That was the problem here. Okay, well, you wanted to challenge me, Blue. Can you write hello world in Zig without standard lib? I mean, I think if we want to do that, Right. So the thing is, I need to figure out. Okay. Well, I mean, to how to do like assembly. Guess I can do it in assembly. I'm pretty sure I remember. Let's see if I remember actually. I need zig. So if I can show you the browser here. So you can do things like this. Yeah, I mean now it's kind of showing the thing, but the thing is like this syscall. This is kind of cheating here because I guess this is a built-in syscall, or no, it's not. It's doing this. Okay. But I need to know how to how the syntax is. Okay, let's just copy this. Fine. These shouldn't be. Okay, so you do this ASM volatile, and this is the instruction, I would assume. But this syntax, I have no idea what's happening in here. Ret equals rax. So usually rax. Well, here rax is both what syscall you're gonna call, and then the return value is also rax usually in this, in the ABI. When you call in assembly you call a function, you get the return in rax usually. And if you're calling syscall, you're gonna call the the kernel in Linux for this one, for example. And there should be a thing. So if you're on Linux, you can do man write. No. Yeah, you would look this up for somehow. What? I don't remember what this is. Yeah, here we go. So write. No, wait. This is a lib function. Yeah, you would have, but you would have to look up somehow the syscalls. And this is kind of cheating. We're kind of making this. Let's get rid of this. Maybe. How does this work? Like returning? Like could we assign a value then? So this is the result. Okay, equals rax. So that returns. I'm not sure, but what is this syntax here? This is so weird. And that's the size of this. Isn't this always a 64-bit though? Oh no, I mean no. Rax is a 64-bit register, but I guess the result depends on which function you're calling. And then number. Oh, these are local. Okay, these are like in. Okay. So this is the number of the syscall. I'm just gonna look this up, which it is. There's a table somewhere.
Here's a table. So you have read and write. So let's do 1 for write. You're gonna do write. Oh, that was the thing. Okay. So you're gonna call set rex to 1. Okay. So this is 1. What is this? Why is this? Why do you do this twice? Is this like a label or I don't know. Yeah, and then the argument. Well, the argument depends on the syscall. So now we can set a bunch of registers to this syscall, and we can. So we have to look up what we send into this write function here. So we have an integer file. Wait, what? Okay, so file descriptor is the integer. So for standard out, that usually is 1, I believe. And then in Linux, and then we have the buffer, that what we want to send, and then how many characters the buffer has. Okay. So, and also, or how many characters you want to send from the buffer. Let's see, where's the thing? Wait. Yes, and then there's like the ABI. So how do you then know what registers to set? Well, it's like a sequence. I think it starts with. Yeah, it has to start with. So here's the sequence. I mean, you can see it here. You start with RDI is usually used for destination things, but here is just, you know, the sequence like arg1, arg2, arg3, and we only need 3, so we only need to know these 3 here. So let's say that the first one, this is the buffer. So let's make a buffer. So let's just make hello world here. So we would put, so this is the message. So we put the message here. So that is now, or I think we need a pointer. So now this is the pointer to the thing. I don't know what this is. This is the first time I ever do assembly in Zig. And I've never done it in C. You know, I just think the syntax is weird overall. It's just a way for them to be able to interface into Zig with this. But, oh, you can just set it here, I guess. Or are these things that you wish to preserve? Maybe. Okay, well, anyway. We have the arguments. So the next one is how much do we want to send? We want to send message length. I don't know if this is correct. Like I'm just repeating these twice here. I don't know if this is correct. Okay, and then we get the result. Now if the result is, I think it's like if it's, no, this is a syscall. If it's positive, there's an error, or is that, okay, let's read the manual actually. Let's read the manual. It returns does it return the number of bytes written is the question. On success, the number of bytes written is returned. On error, -1 is returned. But it's a use size. Oops. Okay, so this is not a use size. It should be like a I guess S64. No, I64. Sorry. Okay, so we can check for errors here, like if result was -1 or less than 0, then we can, there was an error, and we can get the error code as well from, I think, from the negative number here. I'm pretty sure, maybe. But then let's see. Are we done here? Yeah, Rax is 1, and so on. So now we're sending a syscall to write. So now we're actually writing out to the thing. And the thing is, if you were working in assembly, like raw assembly now, you're not done actually, because you have to here make a syscall to exit the process as well. But since we're in Zig, we don't need to do that. Okay, so okay, let's see if this works. No, because there's probably a compiler error. Expected an identifier found later. Okay, so do these have to have an identifier? So syscall function is 1. Oh, so all of these need to be identifiers. Okay, message pointer, message length. I don't know. Let's just see if this works. Oh, I can't use this. So I can't log an error. If there was an error writing to standard out. No, wait, the first is standard out, right? Oh, we need another one. Oh man, which one was that now? RDX. Okay, so this is, no, this is RSI, and this is the pointer. Right, the first was the file descriptor, so this should be 1. That's standard out in Linux. File descriptor. Oh yeah. So let's just, if result is less than 0. No, we can't do anything. Okay. Unused local constant. Okay, let's just forget about it. Oh. Okay, we got something. Hey. You probably want RDF1 to be file descriptor, shift pointer, length over. Can you return things from main? A U8? Ah, U8, yes, okay. Okay, so we succeeded, sorta. I'm not sure what's wrong here. Shift the pointer and length over. Oh, you mean, okay, yeah, you just meant this, place them in the correct place, right? Is there something with the encoding here, or what? No, this should just be ASCII straight up. Yeah.
Yeah, one is out, right? Oh, do I need to wait? Do I need to flush? Message pointer is probably a. I don't think I need to flush. Message pointer is probably. Oh. Is it something with like alignment or something? Many items pointer to. I mean, isn't it more safe to use a C pointer maybe? I don't know. I'll do this and that and this. There we go. Never write C pointers are made used in auto translate. Okay, yeah, I figured maybe you can't actually create C pointers. I don't know. Just to make it message.pointer. Yeah. Ah, cool. Yeah, there you go. No standard library. But I mean, you have to use syscall. I mean, I guess it's coercing this pointer kind of type to this. Yay! Okay. No. All right. Let's see. Okay, let's do this. Let's move things. Let's have an AST. There's a lot of things in there. To unimum, to statement. Yeah, we'll move these things. Let's just move everything here. And I was thinking like you could do I mean, if you do all this parser runs in runtime right now, but technically you could make it run in comp time and have I mean, you can embed the files and read them in comp time. You can also have the source be defined in comp time if you want. So you can basically use comp time for compiling something else, which is it good? Okay, so parser, yes. I'll just do this. No, this is reader. Let's take all of this. Put it here. And I think this has to be a function, maybe, that returns a parser. Wait, where's the node? Or is it make it? Wait. No, statement, I think. No, this returns a list of statements. And then reader.
Unused local variable. Oh. Okay. Let's call parser make, and we get the parser out, and we run it. There we go. Oh, we need the builder. Right. Parser builder. No. No function. No, we need both. Okay. We've reduced the amount of scrolling we need to do. Oh, we don't need you, right? To get to the source code now. Okay. Okay, what do we want to do? I mean, okay, let's do subtraction, I guess. So first thing you do is go to AST, add a subtraction. And basically the same thing except for the evaluation part. Okay, I'm gonna try something as well. That's gonna be the last thing we'll do here. But okay, so now we have this subtraction as an expression. Now we can go to the parser and we can look at add expression. Let's copy this, make this into some expression, subtract, just to not confuse anything. And then I guess we can add this. Here, and now we're parsing a minus there. And we will return a sub, and that's basically the same, you know, the same thing there. And here you can actually, we can do something like a generic mapper from this kind of struct where you have like one an operation and then another one to something that has like left and right. So you can have like two binary expression this binary expression. You take an input, which is 2 expressions and a thing. I mean, this should look the same. And then we return. I guess we have to have a type here. T. And so this one, actually, you know what? We should just make a function that return. Okay. Hang on. We're gonna wrap this in this. Now we're working with functional programming. We're wrapping, return a type. Actually, return a function. Which, yeah, we return a binary mapper function. Which is gonna be, yeah, just take, no, it's gonna take expression, operation, expression, and return, yeah, okay, it's gonna return a T. So this actually has to. Okay, I'm kind of doing the same thing. Let's just put this here. And then we return struct. Actually, let's call this the same thing. With like an underscore because of restrictions. So this now takes these things and returns T. And we can just assume that the only thing we have on this T is a left and right. So this is the implementation of all of these. And now we can say hopefully. I mean, this is just a declaration. Should be able to do this. There we go. Yeah, and it even works with LSP here. We take this, return a sub. Yeah. So a little bit easier to find those. And yeah. Okay. Yeah, now we need to also add this here. Oops. And there we go. Hopefully. Maybe not. Oh, those are not public. Okay. segfault. Oh. Hang on. Okay, let's check this. We have a builder here. Oh wait, but that's a copyable thing. I mean, we are initializing. No, yeah, we're not returning any like pointers or anything. Like that, everything should be working here. So OXA, that's a curious address. Just one A? I recently learned that if you have a segfaulted address OXA and so on, that means that you forgot to set an undefined value somewhere. Oh, these ones. Maybe. Yeah. Okay, because we're using the address here of these ones. So we should actually, we have to allocate these. Yeah. There we go. A segfault at this point, Rust would start yapping. Wouldn't happen if you use Rust. I've never used Rust, so yeah. I'm aware of the like safety things, but I haven't read anything about how it works. But I mean, I know about a lot of things that it basically have borrowed a bunch of features from Haskell, as far as I see. It's just a Haskell wannabe language. Oh yeah, okay, now we need to change this. There we go. Okay, sure. They are const now. There we go. There we go. Now it works. Cool. Okay, so let's see. So actually, now the thing is, okay, so we have this AST, right? And what we can do is, well, we have this eval functions that currently evaluates down to a number. So everything can become a number. But what I'm thinking is maybe what if we evaluate into something else, like maybe like source code or something. Like you could add, let's just add another. Yeah, sure, let's start here. So eval to source. And you would get this. We don't really need the state for that. And then yeah, that's basically what you would do. That's the same thing. So here's one where we can return. Actually, what we do need is like something that we can write to. Actually, let's take a writer. Does this need to be a pointer? No, or yes. Okay, we take the writer. We don't actually return anything. Actually, this could be an error now. Okay, so this one we just do try writer write or print self number. Identifier, we just print that. Assignment. Okay, so an assignment is a statement basically. So in whatever, now it depends on like what language do you want this to be in, and I think we're gonna choose Zig here. So we'll do like const s equals something which actually this could be a format function. I mean, okay, it was basically the same. This is just a format function. Yeah. Can't wait for the SIG async IO. Yeah, I'm curious. I've not looked anything at it, so I don't know anything about it, except for maybe, you know, adjacent programming languages that also have async await. But the plotline seriously considered to port my web app to Zig, even though it might be an overkill for web app project. I mean, yeah, I would try it out on a smaller project and then maybe see how, try out like all the potential issues maybe you could run into. Right, so format, so yeah, that's good. Yeah, and the reason why I wanted to, now it's good because it's format, so I can press F here, and then I can just place value in there. So now it's like, it's gonna use the format function of the expression. And the expression has a format function which goes into each one here. So, okay, add. This is just an expression, so I will say F plus that, left. Need to dereference. Subtract. Was that it? Okay. So now we're gonna get like a basic source out. And now we go back here, and now the thing is we have a list of these things. And we can evaluate each one sequentially, which we're doing here, and then we can also say let's remove this. And we're saying source produced, and then we're gonna log F. Well, actually, this would be that, because yeah, each one is a statement and it has a format function, so you can just pass it in. It will use the formatting function to format the thing. So here we got these things here. So here's the first one, and so on here. Now, since these are statements, okay, I think the assignment one I will change to not do this. We're probably gonna have like declaration instead, like not have the const there. But let's do it like that anyway. Right, and now we can say, for example, you know, you can just add a semicolon after here. Or we can say like, okay, we can say that this is a program. Now I want the standard out here, so let's grab that. And we're not gonna use assembly this time. I'm just gonna get, what is it, IO? No. What is it? File system, file, standard out, I think. Yeah. And then writer. Now we got that. Except I think this needs to be a var. Maybe? Or does it actually? No. This is a file writer. Not a generic writer. So let's write write all pub function main and here we want to use try standard out print. Okay, maybe it does need to be that. Oh yeah, we need to add that. Let's just add one here for and let's add some indentation. There we go. Now we got ourselves a little main. So now we can compile or transpile or whatever you want to call it this language into Zig source code using a Zig program, and I can include it in like a build step if you want, and you can yeah, we can include it in a build step so we can generate basically Zig stuff with this parser and AST and stuff. So now what I want to do is I want to basically do that this program is gonna do what my sort of interpreter is doing, and that is to log. Also we need to import standard library. And we want to log info except if it's an assignment, we don't want to do that. So we could say switch assignment, we just do that, else so if it's an assignment we just put it there. If it's another thing, expression, I guess. Yeah, this is like expression. We will do that. So we know that these are always floats, so we could just do this. And that. There we go. Okay, now let's disable all of this crap. So which output do we get now? Do we only get this output now? Yes. Yeah, so we can do sig build run out sig. Yay! Oh shit! There's an error here. There we go. All right. So we basically, yeah, we kind of made a little programming language here. All right, I think I'm gonna be good with that for this thing. I mean, it's kind of fun to do this, and you can actually use it to implement. You know, if you wanna be able to define. I mean, you can even, okay, so instead of having this as a string, you could just make a file. Yeah, let's do that as the last thing here actually. So let's see. So we need some sort of file to read. So now we change this guy. Actually, we can keep this here. The source, actually the source could be a union enum. Either it's a buffer or a file name, or maybe even a, no, let's do a file name. So this one is the source. And then we get the reader. So the reader here, do we need more of this interface actually? We probably want to have the file open. Or we have some way of closing the reader or something. Let's actually just take a file in here for now. So we'll take a file in, just, yeah. And we assume it's always like open here while parsing. And then here we say, so here it's like if or switch on the source. If it's a buffer, we do this that we did before. If it's a file, we this is where it gets weird, because if we do reader, that won't work. Wait, no, reader. What happens if you put, so I know for writer you can pass in an empty buffer. For reader, what happens if you put in an empty buffer? I don't know, I guess we'll find out. And we return this reader, that should be fine, right? Yeah. We're just copying it over here. Since it's an empty buffer, that should be fine. Okay. And now, oh yeah, we also need to do this here. Actually, you know what? This is not, actually this isn't fine. This is not fine. Because this is a file reader, it's not a... Ah! You know what? Let's just have a optional file read. So let's have this here, set it to null. If we happen to have a file, we will set our file reader to be this. And then we return this. Will this work? I don't know. We'll see. Reader, discard. All right. Okay. So now here we can either say like if it's a buffer or a file. So if it's a file, we need to call this input file. And the input file we can get from, you know, the command line, or you can, but let's just get it. Let's just say that the name is like in dot, I don't know, lang for some kind of language. And let's call this like noob for newbie language. And let's get then this file open. So input file. Let's do, actually we need to do like current working directory, open file, subpath is this, flag, read only, yes, defer, close. Oh yeah, so let's just catch this and couldn't open input file or enter file. Alright. So there's our input file. Do you need to be a pointer here? No. Great. So now we should be reading from this file, and we should get an error saying we can't open it. Yeah. So now if we open this and we say, we copy this over, we reached unreachable code. I see. This is probably what happens when you have a 0 length buffer in your reader. So what we do is we make an internal buffer of like, I don't know, a page. Like this. 6, right? 1000 80 60 U8, and this is undefined. So now we have a buffer, and we can use it over here. So this will be self buffer. There we go. And we got a seg fault. In the writer. Actually, yeah, we need to make sure that this reader is always a pointer. I'm just gonna make sure that that is the case. Yes. This points to here. And this, yeah, so this now just has the pointer, so now we're good. So what is going on? Read failed, seg fault. I think what's happening, we have some error, and then when it tries to print the error, there's a seg fault. So it could be something wrong with the errors. Whoops. Okay, let's just look at the thing here. Writer, log root 72. Yeah, there's something wrong. Oh, the file. Yeah, we got file. I think it's maybe the error is the file then. Okay. Now what is going on? I'm guessing it's the read failed. So it says read failed. That's fine. And then when it tries to write at error file, it fails. Right, that makes sense. So this fails. But why? This is where you start. This just sets it to the same thing. It's kind of weird that that was where it fails, because unless no. I mean, okay, maybe the error is like bogus. Okay. Let's forget about the file for now. Oh, switch on corruptible. I've never seen that. I was like, what the hell is happening? But then I realized, okay, it's probably just switching on a corrupt value. 267. This result is corrupt. Interesting. How can this happen? This is very strange. mean, it might have to do with the restore, maybe. It's kind of weird. It's the same program though. The only thing we changed is now we're reading from a file. Instead of a string in memory. Oh. You know what? Let's see here. I think the problem might be here then. Like the file is still open, right? We could close and open it again, or we could just we could try and reset it. Like, I guess we can seek to, yeah, can't we just seek to the index? And or just do this. Yeah, it was okay. If we have one, so if we already have one, we will seek to index and then we'll return the reader. Okay, will you seek to we'll do this. If this is null, we set it there we go. We seek to index, we return the interface. Type enum numerals for field access. Oh. Wait, is ampersand an enum literal? What? Error unions to ignore. Okay, try. Yeah. Now the problem is that this type of error is not part of the parser error list. Where is that root? Yeah, let's just get rid of this, I guess. Or we can do this. Let's do that. Or seek error. Or oh, that's it. Let's look for these. And we'll change you to error. Oops. Okay, that's it. Oh. A read failed. Man, okay. Seek error, end of stream. It's the same thing. Okay, unseekable access denied or unexpected error. Okay, so there's a whole bunch of weird errors. Let's just say everything here. Else error error reading source There we go. So now we're running it. We still get this. So does the interface need to be mutable then, or maybe it's something else? I guess we'll do it to make sure nothing weird is happening. Let's do that actually as well. If readers we should get a whole bunch of compile errors. Oh yeah, this is no, oh wait, no, this is not a pointer. There we go. That should not be a pointer. It should just be a place where it can't be. So then we can use that place as a pointer. So this would be, now that works, but then when we return it, we have to do this. Right. And, but this one just copies it though. And we're back to square one. Okay, let's just. Okay, get reader. Yeah, this returns a pointer. 49. Okay, now you are a pointer. 78. Oh, there we go. Okay, read failed, couldn't parse source remove. Read failed for some reason. Okay. But we did open it. So, okay. We got a read failed. Yeah, we got read failed error. Okay. Sometimes all right. Okay, I'm just gonna do one more thing. Instead of reading, you know, instead of streaming the file, what I'm gonna do is I'm just gonna read the file you know, all in once to get a string here. So I'm just gonna read all, and we'll put this into some buffer here. Let's do like, I don't know, a megabyte. Read all, and then catch error, couldn't read file. Oh, let's do like source. Right, so now we read the file, and then we'll close it over here. Okay, so we got the file. So this should be the, oh, that's the number of bytes read. Okay, well, let's do like, so this is like source length. Source is buffer 0 to source length. Okay, so now we got the source, and instead of doing file, we will do just the normal, the first one, the buffer. There we go. That should work, right? There we go. Okay, so now we basically, if we do this, we open this, and we open out. And if we, for example, remove all this and run. Oh, oops. No, we have to do this. Actually, let's do that, because I think that will, so we just set you to that. Yeah, and here you can see. And then I will say x plus 5, and that will update. So you can you can do this as well. But I mean, the point is that you can basically build up any kind of language you want, and then produce some kind of you know, scaffolding or more easily defined things in Zig. So you could more easily sort of, I guess, I mean, easily is, but if you would have this language already, it would be maybe easier to use it. We'll see. But then there's also the thing of like, okay, diagnostics. Well, okay, if there's something wrong here, if I do like that, it will say at 1.9 expected plus actual this. So you can actually, like those kinds of, you can make it so that NeoVim basically, well, if we would have the file name here, it would be able to pull this into the diagnostics and put it in an actual error message that you can see in NeoVim. And then it's basically, and then you can also add like syntax highlighting is pretty easy to add also. And then you know, then you have your little toy language there that compiles to something else. Can compile it to anything. Okay, but anyway, that's gonna be it for this time. So thank you very much for joining me here, and yeah, hope you have a nice day, and I'll see you later.